customer makes exactly one selection from each of the 5 categories listed above: 10 ice cream flavors, 8 kinds of candy, 5 liquid toppings, 3 kinds of nuts, and with or without whipped cream, what is the greatest number of different ice cream sundaes that a customer can create? First of all, is the order of the ingredients important? Since the order of the ingredients is irrelevant, this problem involves combinations. Of 10 ice cream flavors, we're choosing one of them. Of 8 kinds of candies, we're choosing one of them. Of 5 liquid toppings, we're choosing one of them. Of 3 kinds of nuts, we're choosing one of them. And with or without whipped cream, we're choosing one of them. Finally, we're going to apply the product rule, since each kind of ingredient is a single task. Do not forget that. And combinations of n objects, if you're choosing just one of them, equals n. Therefore, 10 times 8 times 5 times 3 times 2. 5 times 2, 10. 8 times 3, 24. So we get 24 times 10 times 10. 2,400. Choice C is correct. There are 6 men working in a factory. In how many ways can a 4-man committee be formed? First of all, is the order of the members of the committee important? Since in a committee the order of the members is irrelevant, this problem involves combinations. Of 6 men, we're choosing 4 of them. And this one is equal to 6 factorial over 4 factorial times 6 minus 4 factorial. First of all, we need to solve this one, which is 2, and we get 6 factorial over 4 factorial times 2 factorial. 6 factorial is the same as 6 times 5 times 4 factorial over 4 factorial times 2 factorial is 2 times 1, which is 2 at the end. Now, we can cancel 4 factorial with 4 factorial, and we can cancel this one, and we get 3 on top. So finally, we get 3 times 5, and this is 15. We can form 15 different committees of 4 men out of these 6 men working in a factory. Choice B is correct. How many different 6-letter words can be formed using the letters of the word repeat? Now, first of all, is the order of the letters important? Since the order in which the letters are arranged matters, this problem involves permutation. Now, repeat is a word that has 2 E's. Therefore, which formula shall we use? We need to use the formula of permutations with repetitions because repeat has two indistinguishable elements. Therefore, permutations of 6 objects where we have 2 indistinguishable objects, and this is equal to 6 factorial over 2 factorial. Now 6 factorial equals 6 times 5 times 4 times 3 times 2 times 1 over 2 factorial is 2 times 1, just 2. So finally we can cancel this one and this one. And finally we get 20 here, and over here we get 18. Finally 18 times 20 equals 360. Choice C is correct. How many 3-letter words can be made using the letters of the word smart without repeating letters? First of all, in order to make new words, will the order of the letters make a difference? Since the order in which the letters are arranged matters, this problem involves permutations. Only 3 different letters of smart must be used. Therefore, we'll use a formula for permutations when the size changes. Out of 5 different letters, we're gonna choose just 3 of them, and this is equal to 5 factorial over 5 minus 3 factorial according to the formula. This is 5 factorial over 2 factorial, and 5 times 4 times 3 times 2 times 1 over 2. We can cancel this one with this one, and finally we get that permutations of 5 objects, choosing just 3 of them, equals 5 times 4 times 3. That is finally 60. Choice D is correct. Felipe VI and other 3 kings are scheduled to sit in a circular table of 4 chairs. How many different seating arrangements are possible? Now, first of all, is the order of the kings important? Since the order in which the 4 kings are going to sit matters, this problem involves permutation. They're sitting at a circular table. Therefore, we're gonna use the circular permutation formula. Circular permutation of n objects equals n minus 1 factorial. In this problem, n equals 4. Therefore, circular permutation of 4 elements equals 4 minus 1 factorial. Finally, we get 3 factorial. 3 factorial equals 3 times 2 times 1, which finally is 6. Choice B is correct.